You can also use the universal gas law, PV equals nRT, to find the density of a gas. So first, let's remember what density is. So you have 3 cubes, and I know these are squares, but they have to be three-dimensional so you can measure the volume, okay? So you have 4 cubes, and pretend they're all cubes. The density would be how much it weighs. So this would be 1, 2, 3, 4, 5. 5 grams for every, let's pretend this is 1 centimeter by 1 centimeter by 1 centimeter. It would be by 1 centimeter cubed. So this is 5 grams per centimeter cubed, 9, 17, 42 approximately. I didn't actually count those. So as you can see, this has the highest density because there's so many of those atoms or molecules in the same amount of volume. So it's more dense, more compact. Okay, so that's what you should think of when you're looking at density, how compact the atoms are. You can also look at the density by the mass of the atoms. Of course, you're comparing the same volume, so I drew another cube here, and the same number of particles. So this is both 1 centimeter cubed, okay? But each sphere, this one weighs only 1 gram, this sphere weighs 5 grams each. So it'll be 5, 10, 15, 25 grams per centimeter cubed. So as you can see, this is definitely more dense because each particle weighs more. Okay? So we are we're going to find density of a gas. So imagine something that looks like this. Remember, the density of a gas is going to be based on the variables pressure, volume, moles, and temperature. Okay? So to use this formula, we have to solve for density. First, we have to know the formula for density. Density is equal to, this is the mass in grams, over, this is the volume in centimeter cubed. Okay? So this is the formula for density. For our purposes, because we're using gas laws, we're going to find the mass of a gas in terms of grams, that's the unit, and the volume is going to be in liters. Because a centimeter cube for gas is not going to be much gas in there because it's too small. So we use per liter. Okay, so to solve for a formula for density, we start with PV equals nRT. PV equals nRT. The next step is to substitute. Because density is equal to mass over volume, I see the V right here, but I don't see M. So we have to change this into M, little m over big M. We have to substitute that inside there as well. So PV is equal to, little n is equal to M over big M, and then RT. Okay? Once you've substituted, that's the first step. You just have to isolate M over V to one side. Do whatever you can algebraically. Okay, so remember, I just want to get the M on one side and the V. So what I will do, the easiest for me, is to multiply both sides by M. And that will get rid of the M here. So I have MPV is equal to MRT. Remembering that I want M on one side, so I'm going to divide by what? Right, RT. Okay, so what I have now is M is equal to MPV over RT. So what do you think I should do next? Remember, I want M over V on one side. You're right. I should divide both sides by V. And that cancels. So M over V, which is density, is equal to all of this. MP over RT. This is P. MP over, just rewrite that, looks messy. MP over RT. Okay, and this will be equal to density. Okay? Again, you are not allowed to memorize this. You must derive it all the way from PV equals nRT. That way, just memorize one formula and you can get the density of a gas, the molar mass of a gas, and all the other gas laws. Now let's use it. We are going to find the density of carbon dioxide in Mars, and we're going to find the carbon dioxide in this room, pretending we're in the lab. Okay, in Mars, I had you look at this document here, and it tells us the temperature and pressure. So to get density is equal to this formula right here, MP over RT. Okay, that's this formula. So first you have to get M. Big M is the molar mass of CO2. So C is 12.01. 2 oxygens is 16 times 2 is 32.00. So we have 44.01 grams per mole. Molar mass of CO2, 44.01 grams per mole. Okay, you must write the units here. The pressure in Mars, you had to find it, and it says it's 600 pascals. Okay, of course it varies, but we'll use that number, okay? Of course, I'll give you the pressure on the test. So 600 pascal, 101,300 pascal is 1 ATM. You have to convert it to ATM. Okay, so let me calculate that. 600 divided by 101,300. 0.00592 ATM. 0.00592. So you can already tell that we're not going to survive in Mars because that's not a lot of pressure. We would explode or implode. We would explode. There's more pressure inside us. There's about 1 ATM inside us. Okay. R is 0.0821 LATM K mole. Okay. Temperature in Mars. I had to look that up, and it was an average of temperature in Mars equals to negative 60 degrees Celsius. Okay, I'm going to add 273 to that. Really cold. It's cold and there's no air. Very thin air, but also it's mostly carbon dioxide. 213 K. Right? So write that down here. All right? So when you plug that in the calculator, you go 44.01 times 0.00592 divided by button, 0.0821 divided by again, 213. You should get 0.0149. The units are very important that you cancel out here so you can see that you're doing it right. ATM goes away, K goes away, mole goes away. And the only unit left is G and L. So grams per liter, does that sound like a density unit? Mass over volume. As written here, I told you that I want my unit to be grams over volume, grams over liters, okay? So that checks out, which means I must have done the problem correctly, okay? Now we're going to compare the density of CO2 in this room. Here are the conditions. Pause the video and try it yourself. Okay, so density equals MP RT equals, same molar mass as the same gas, 44.01 grams per mole. Pressure, 1 ATM. Oh, I love that. So easy. We'll pretend we have infinite sig figs there. I know I didn't really write that. R, 0.0821 LATM Kelvin mole. To help me remember this, sometimes I say Latam Camol. Okay, and then temperature, 23 plus 273 is 298. I'm sorry, 296. Okay, go ahead and when you plug that in the calculator, I got 1.81 grams per liter is the density. And again, the units, moles are gone, ATM's gone, K is gone, and it's grams, liters, and grams. Okay, and that's it.